Welcome to the presentation about understanding and producing histograms. Histograms look a lot like bar charts, however there's some big differences. The first big difference is that for a bar chart the frequency is the height of the bar. As for a histogram, frequency is equal to the area of the bar. Next difference, a bar chart can have gaps between bars, where a histogram has no gaps between bars as it is dealing with continuous data. The third difference is that a bar chart will have equal bars in terms of width, but a histogram can have unequal widths to its bars. Another notable difference is that on the left-hand side of the graph for a bar chart is frequency, and on histogram it is frequency density. So if we look at an individual bar taken from a histogram, we can see that on the side we label it frequency density, along the bottom class interval, and the area is the frequency. So how would we calculate the frequency? Frequency is equal to frequency density times class interval. How would you work out the frequency density? That is equal to the frequency divided by the class interval. And to work out the class interval, you would do frequency divided by frequency density. What is the frequency of each of these bars? So to work out the frequency, we need to know the area. So therefore we need to know the length and the width of the bar. So for A, it's 10 by 2, making the frequency 20. B, we can see it starts at 105 and continues to 110, so that's a class interval of 5 and a height of 6, giving us a frequency density of 30. C is 10 by 10, frequency of 100. D is 5 by 8, giving us a frequency of 40. Now we can use the table and the chart to find missing information. If we start off with using the chart, we can take the bars that we have, and we can see that for B, the width is 40 and the height is 0.4, giving us a frequency of 16 because that is equal to the area. For C, we can see it is 20 in width and a height of 0.8, giving us an area of 16, hence the frequency. And for E, it is 60 in width and 0.2 in height, giving us a frequency of 12. Now, if we look at the table, we can first of all look at A. We know that the area of the rectangle is going to be 4, and the width is going to be 40. So therefore, we can work out the height, which is going to be 4 divided by 40, 0.1. And then for D, we can see that the width is 20, the area is going to be 12, and therefore giving us a height of 0.6, and then you would be able to draw that onto the chart. So in recap, frequency is equal to the area, the frequency density is equal to the height, the class interval is equal to the width of the bar, and frequency density is calculated by doing frequency divided by the width of the interval. Why would we use histograms? Histograms are good for looking at the distribution of data. So if we look at a normal distribution where we have some numbers which are lower on the scale, some numbers that are higher on the scale, but the majority is somewhere in between. Then we have where the information is skewed to the left, so that means that many of the population is on the lower part of the scale. Skew to the right, more of the data is to the higher part of the scale, and then of course in the last example there is no real distribution, it's random.